Anyway, thank you so much. Okay, so now we're recording. Yes.
Yeah, so can we just like look at number one, for example?
And that was 14.4?
Yeah, we can't see your screen though.
I know. Okay. There we go. Okay.
So what I did was I went to y equals and typed in 8 minus 2x.
Mm-hmm.
And then, or for the first one,
Yes.
and then for the second one, I put in the 4 value and I hit graph.
Mm-hmm.
And then I went to second trace, went to the number 5 for the intersect.
Good.
And then the first curve, it just automatically gives it to me if I hit enter. So I hit enter again, and I hit enter again, and the intersection says it's at 2.
Good.
But when I do it, that's not the right answer. Like, if you put in 2, it wouldn't be right.
No, 2 is not the answer. 2 is your limit of integration.
Oh, so that's half the problem?
Maybe not even half. It's a start. Let's go here. So what you found is let's see. Yeah. Full size. Get this thing down. So we've got P equals 8 minus 2Q. P bar was equal to, was it 4?
Yes.
Okay. And when you found the intersection, you found where
Wait, what's the difference between P and P bar?
P bar is the actual price that we're going to charge, which if it's a consumer surplus, it's lower than what people are willing to pay initially. And you can,
okay.
Yeah. So, and then what we found is when you found that intersection, you found Q bar, which is equal to 2.
Okay.
And then, let's see if I got to think back to what we did here. What was the formula? Formula was something like going usually from 0 to Q bar. And then it was D of Q, which actually this P is the same thing as D of Q. It's a function of Q. It's the demand function. Minus, I think it was P bar, right? Yeah.
So 8 minus 2Q minus 2?
So you'd get 8 minus 2Q minus 4, but you would integrate it from 0 to 2. So the 2 that you found, it becomes your limits of integration.
Okay.
Okay, so now you need to integrate this, or I mean, you could simplify it a little. It becomes minus 2Q plus 4. So now you could type this function into your calculator and just find the integral from 0 to 2, and that will be your answer.
How do I do that with my calculator?
Let's see. Here's my calculator.
Oh.
Actually, my calculator is deactivated. I haven't purchased the license yet, so I'm gonna have to do that. You put this into, so I can just walk you through it. You do, y1 would be the integral. You graph it. You do second trace. which is the calc function. And then you do number 7, which is the integral function. It'll ask for the lower bound. That'll be 0. You put in 0 and then enter. For the upper, you put in 2 and enter. And it'll draw the graph. It'll show you that it's getting the area under that curve, and then it'll give you the answer as well.
So 2, so 4.
It could be 4, yeah.
Okay.
Whatever it ends up being. So
I have a question. How do you
Yes.
find the bar? So how do you find?
So for the bar, for Q bar, right?
Yes.
So Q bar, we were doing the graph. It's really where this value of 4 intersects this graph. So you could do it by hand simply by taking 8 minus 2Q equals 4. Or the other way graphically is you graph both of them and find the intersection. But here, watch, we'll subtract 8 from both sides. So you get negative 2Q equals negative 4. Divide both sides by negative 2. So you get Q equals 2. Now Jacob did it graphically, and he also got Q equals, or actually not Q, Q bar equals 2. Because that's, since this was P bar, what we're finding is Q bar as well. We're finding the value of Q where it intersects. And again, what that ends up being graphically,
So would it be okay to have a negative Q value? Because I did it by hand. Mine is 20 minus 2Q, and then P bar equals 4. So when you solve that, you get Q equals negative 8.
it doesn't, the problem with that would be, that's a negative demand. So that doesn't, well, it's possible. So what's the function you have?
So mine is 20 minus 2Q.
2Q.
And then P bar equals 4.
Okay, yeah, so you're going to have, so you're going to get 20 minus 2Q equals 4. So when you subtract the 20, you get minus 2Q.
Yeah, so it's just 8. Okay.
Yeah, so you'll get a positive. Yeah, you're right, because a negative would mean negative, because remember Q is the amount of demand, so you wouldn't want negative demand. We want to have some positive demand. So that's a good, if you come up with a negative, something went wrong. And that's what I usually do. I drop off a negative somewhere. Good.
Can you go back to the other page and show us the, oh, there it is. Never mind, right here.
Which one?
The one you're on, thank you.
This one? Yeah.
The one you were just on, sorry, I wasn't looking at the screen at the time.
Sorry, let's see, let's go back here.
Yep, perfect, thank
you. Could you also walk us through another one, or after you're done with this one?
Sure.
Because it's just like a little variable that gives me a twist. It's number 3. I did the same way you showed us to do with number 1.
Okay.
But I don't think I did it right. I must have slipped a finger somewhere, pressed it, I don't know.
Okay, sure. See, so everyone got this part? So number 3. Let's get a, we'll come up here. We'll call this, we'll just do number 3 up here. So again, the way we figure out Q bar is going to be where these, where P equals P bar. divide by 700. E to the minus 2q equals, let's go 9 over 70.
Wait, is there not a way to do it with the calculator?
Sure.
Okay.
Except I don't have a calculator that's, I mean, I could use Desmos. But yes,
Yeah,
you could.
Desmos is great.
Yeah.
Can we use Desmos?
Sure, sure. So you find the intersection of these two?
I think I found it.
Okay.
I used my calculator though. I don't. Maybe I did it wrong, but I used my calculator the first time around. So maybe I did it wrong. But I got. If we're going to the third, which decimal we're going to?
I think they want you to round it
Near cent. Okay, so 2.
2 places. So you would definitely want, what they've been showing, at least in the examples I've seen, is they go to 4 decimal places just to make sure you have enough.
But these are dollars.
Yes, but I mean, when you get Q bar, you should go to 4 decimal places.
Okay.
So that when you round it to 2 decimal places, you're not off by a cent.
Okay.
So this was what? Y equals 700 e to the minus 2x.
Yeah.
And then the second one will be y equals 90.
Yeah.
And so we're going to have to kind of come out here a little bit. Let's go in a little bit. So we get the intersection point here is 1.026. Again, decimals doesn't do much. So, but 3 decimal places, I guess it'll just have to do. And again, you could have done that with the logarithms. And so what we want to do is we want to integrate the function. And remember, this is really just the area between 2 curves. This gives us the price people were willing to pay for it, but the company's offering it at a lower cost. So we're getting the area between this $90 cost and the actual curve. And so then we go from 0 to 1.026. These will be our limits of integration, dq. And again, you can put this in the TI calculator as y1. And then when you graph it, you do a second trace. And you do number 7, which is find the integral. And then again, the lower bound is 0, the upper bound is 1.026. And at this point, I can't do that because my calculator license is gone, and I'll get through that and do some over the weekend, but that will give you a correct answer. Now, if you use the TI calculator, you might have a 4th decimal on this. It might be 2.5 something, or it might be 2.6, whatever. If you go to 4 decimal places, but 3 decimal places should give you an accurate enough answer when you round it to 2. I would think, but that should give you an answer that should work.
Excuse me, Professor.
Yes.
I have a quick question that can be a little dumb because I understand the process, but sometimes it becomes tricky. How do you decide when you're using technology and you should do like y1 minus y2, and then you should do y2 minus y1, and like in which cases you just stick with one subtraction when you need 2, and how do you decide which one? Like I remember you're looking for intersections, but in cases when you need to find the line which is on the top, how do you find this line which is on the top? Because it becomes tricky sometimes.
Very good question. Very good question. So let me just give a graphical. I'll just make up a graph here. So we'll have one here, and let me just draw 2 sort of random graphs, 2 different colors. We'll do a blue one I'll make it go something like this. So that's kind of a cubic. And then we'll make a quadratic that maybe goes like this. Okay, so and it all depends. Let's say this is 2, and we'll say this is 1. So what we have to do is we have to find these points of intersections. And then to answer your question, it all depends on what the limits they want to integrate over. So say on this, but so let's label this. This will be g of x, and we'll make the blue one f of x. Now, if we're just going between, say, 2 and 1, let's see, here's another. Make sure I get everyone in there. If we're asked to just go between, oops, that's not 2, that's a -2. Say -2 and 1. Then we're just going to have really one integral, and that's going to be f of x is on top, and g of x is on the bottom. And the only way we know that is visually. We have to graph it and we see it, okay? Or you could look at a table of values, but the y values of g of x are always below the y values of f of x on this in particular interval. So had they asked, and again, they could have done this differently. They said, well, what about the interval from -3, let's just be obnoxious, and go to 2, okay? This one's actually going to have 3 different intervals, right? Because here's -3, here's +2. So we've got, what this would give us, we do one interval, actually let me finish this one. This would have gone from -2 to 1 and we're all good. This one will go from -3 to -2, -3 to -2, actually g of x is on top, minus f of x. Then we'd have to do an integral from -2 to 1, with f of x on top. And then we'd have one last interval from 1 to 2. They're not going to do this to you, but they may give you one where there are 2 different intervals. But this last interval, we would have to add on the interval from 1 to 2. And that one has g of x on top again. Okay, so it's all visual by looking at the graph. And then looking at, so it's a combination of the graph and the limits that they give us and where the graph intersects.
Okay, it makes sense. And that's why we are looking for intersections to see where we actually can do those boundaries.
Yes, exactly. That's why you have to find those intersections. So the steps is really to graph it, find the points of intersection, and then you compare to whatever interval they're asking for to see maybe how many different ones, whether you, and again, but everything I've seen so far, you either do it in one interval or you might have 2. I hadn't seen one that would give you 3, but I mean, it's possible, and could even get worse, but it won't. We'll just give you one. I know there's one, at least one, where there's 2 different intervals where it does change, and that's enough to get the concept down.
Got it. Thank you very much.
You're
I
welcome.
have another question, Professor.
Yeah, you got it.
So I know I get the consumer surplus. We obviously just did that, but is the producer surplus any different? I know it's a slight different. It must be slightly different, correct?
Yeah, it's the subtraction is different because the curves are different, and so that's why that's a good thing. Is I in the video I say just think of these 2 as an area between a curve. So if you graph the 2, you'll see that the producer surplus is the function. The function is reversed, and now I'm not sure I've got my. I gotta think, did I have my consumer? Yeah, for the consumer it was correct, I believe. So it just switches the order of the subtraction.
Meaning the P bar goes first, and then regular P goes minus.
Yeah,
Gotcha.
yeah, exactly.
Okay.
You got it.
Thank you.
You're welcome. So, but yeah, that's the difference. Go ahead.
I have a small question. Well, it's kind of small. For number
Okay.
4,
Uh-huh.
on the same one that we were working on,
Let's see. So good.
for the final answer, I keep getting a negative number, and I don't think I'm doing anything wrong unless I'm understanding the question differently.
It may be that you've got the subtraction in the wrong order. That's probably what would have happened. So number 4.
Yeah, number 4. So mine is 10 plus 2q. P bar is 14. So yours is about the same. So you would get a negative number as well if you're doing it the way I'm doing it. So,
Okay, so you should, so for number 4, you have 14 instead of 16?
yes.
We'll go ahead and use it. So you get 10 plus 2q minus 14. So this will be negative, but the area you should receive, because you're going to go from 0.
Yeah, I went to 0 to 2.
To 2. Yeah, that would make sense. And so if you go from 0 to 2 with this, you get, let's see, 2q minus 4. P bar at 16. 2q, and I guess if you were to graph this, yeah, your graph actually starts, it's got a y-intercept of minus 4. So it's going to go like that, and going from 0 to 2, you're going to get a negative value. Let's see, what are we doing? P.
Well, see, in the questions before, it's asking for the indicated unit price for the demand. But this one's asking for something a little bit different.
This is asking for producer surplus. So this goes right back to the question Jacob was asking. Producer surplus. So yeah,
I still got it wrong though when you told me to do it the other way. I don't know if I just messed it up somehow, but
okay. Well, let's talk about this one. So the problem with this one is this has to go first, and then we're going to subtract this part. Okay, for producer surplus, we get P bar.
Should it be like negative? Would it be like, so you're like saying it would be negative 14 minus 10 plus 2x? Is that what you're saying?
No, it would be positive 14 minus 10 minus 2q.
Okay. Yeah.
Okay.
Oh, I see.
So just make sure you have this parentheses, because this negative is going to have to distribute to both of them.
So it'd be 2q plus 4.
There you go. And that'll give us a positive value. So your value actually probably, yeah, your value was correct. It just, so you could have done it that way and just say, hey, negative doesn't mean anything. Your value would have been correct. So just recognize that, yeah, we can't really have, because what we're getting is the amount of demand and maybe the amount of surplus. Surplus is a positive number all the time. So even if you make a mistake and you get a negative, just put it in as a positive and you should be okay. But then think about that. That's the basic difference between producer's surplus versus consumer surplus, is which one we're subtracting.
Okay, thank you.
So, okay, good. That was don't often get that happening, but that was a very good order of questions that came up. Because I overlooked that was producer surplus. So I started working, and that's my problem, is I don't always read real clearly because I'm dyslexic. So I look at the numbers and I just start working things. But when we weren't getting the right answer, I look back, this is producer surplus versus consumer surplus. So it's very easy to get into a pattern and just keep doing it. But then question 4 and 5 really flip it on us. But at least the good news is that's, we get that negative answer, and then that doesn't really make any sense. And to look back, and that's usually the issue, is the subtraction is going in the wrong direction. Good. Thank you, guys. This is what makes class learning, is this interaction. I mean, I can make videos all day long, but I might miss stuff like this. And
yeah, to be honest, I kind of prefer this. It's easier to ask questions rather than raising your hand at the back ass to the classroom and hoping you get picked.
Exactly. And you guys are taking advantage of it. You know, we get 10 or 20 of you, this is good. But the thing is you guys are coming up with real live questions that those who aren't able to attend, they can watch later, and they probably have the same type of questions you have.
Yeah.
So good.
I'm going to flip it backwards on you.
Okay.
I have a question from 13.4.
You got it.
It's not how to do it. It's just I've done most of it. There's just a couple questions that I know how to do them, but when I plug in the exact answer, it's saying it's incorrect. So I'm wondering if I need to plug in like when I plug in like the numerical answer, it's saying it's
Okay.
incorrect.
Yeah. Which one is it?
So I was doing 4, 5, and 6 are wrong because I put in the numerical answer. So I'm wondering if
Exactly.
I just need to put in.
I can tell you right now, 4 is going to involve a logarithm, because when you integrate it, it gets a log, and they want, for all of these, they want what they consider an exact answer. So the numerical is not going to work on any of these. You have to really do these by hand. You plug in the limits. Number 4 is going to involve a logarithm. 5 and 6 will both involve e to some power. And when you do it numerically, you get a repeat or a non-repeating decimal, but what they're looking for is the exact answer. So 5 and 6 will involve the e.
Okay, perfect. Just needed to know.
Okay, good. And I found out the kind of your way. I did all of those electronically. It wouldn't give me the right answer, so I went back and changed and did them that way. I forget what I've done, but I think I've got a few examples of how I went, especially this one with the logarithm. I'm hoping I have one. If not, we'll go through it. But I think there is an example of how to do that one. Good. What else do we got?
Professor Little Crow?
Yeah.
So for LNEX, like if you like set it up, like does it afterwards, it goes to X, right? After you set the number after it is also LN. Oh, this is for 14.2.
14.2. So tell, like, for number 4, or I'm not sure I understand the question. Let's see. So you're saying, let's see. Let's take a look. Which one of these
So
are you?
like, I know how to do number 5, and it's like LNEX equals to 3, but then you put also the LN to the 3, right?
Oh, okay. Yes. Okay, I see what you're saying. So we've got e to the x equals 3. So what we're trying to do is find the intersection. And yeah, you take ln of both sides. And I think now ln of e to the x comes down. Ln of e is 1. So that's just x equals ln of 3.
So LNE always equals to X if you do it.
Yeah, when we do it this way, we will always get x equals to the ln of 3. And what we're getting is we're getting the interval of integration. So the ln of 3 goes here, and usually, let's see, they going between the y-axis, or here they're saying x equals 2 to 0. And when they say y-axis, they're saying x equals 2, or sorry, x equals 0. So once you find the point of intersection, then we're going from 0 to the point of intersection, from 0 to 3, natural log of 3. And then this is what we're doing, the area between two curves. And I think we've got e to the x, and we've got 3. I think 3 is higher initially. So we get 3 minus e to the x dx, something like this. And then we integrate that. And this becomes the integral of, and then when you do plug it in eventually, because this becomes what? 3x minus e to the x. When we integrate it, we go from 0 to natural log of 3. So you get something like this. And e to the natural log, that's just going to become 3. And then you subtract 3 times 0 minus e to the 0. So this part is fine.
It's 3 ln x minus 2.
And then this is a minus. E to the, this is e to the 0 is 1. This is 0. A negative makes it a positive. Oops, not 2. I was thinking it positive 1. And yeah, then you get minus 2. There you go. Does that help?
And for the y equals ex and y equals x, do you use the same setup?
And then they get y equals x. Yeah, you would use the same setup. Let's see. Do they? The thing is, though, we don't have to find the point of intersection because they give us, it's going from 0 to 2. And I think what you'd want to do is graph it. I think e to the x, it graphs like this. Maybe we do. You might need to, this is y equals x. So since you're going from 0 to 2, you just need to make sure that wherever they intersect is either within 2 or not. Let's do that real quick. Let's go to decimal. So we have e to the x, and then the other function is just y equals x. And then let's get down here. Okay, yeah, we're safe because they actually don't intersect at all. So we want to go from 0 to 2. So the e to the x is always on top. We don't have to find the intersection, which is good because they don't intersect. And so we're just going to find the area between these two curves from 0 to 2. Let's see. Let me find a. So for that one, since they give you the integration, you're going from 0 to 2 e to the x minus x dx. And so your 0 and 2 is what you plug in, and you integrate this, and you plug in the 2, and you plug in 0. This one won't involve a natural log.
Okay.
Okay. And again, gets back to Victor's question. The only way I knew that was by looking at the graph. And I saw that 1 is always on top. So that's, okay, we're only going to have one interval. And they gave us that it was going to go from 0 to 2. We don't have to find the intersection in this case. Again, that's good because there is no intersection. But it's one of those things you really don't know until you look at the graph. Unless you know graphs very well, which I don't have them all memorized myself. So good.
I have a second question for number 9 on 13.4 as well.
Number 9 on which one?
13.4.
13.4.
Let's do today. I'm just crunching them out.
Okay. 13.4.
Can I get the next question after this?
Sure.
So I was just confused on what the x-axis, what's the point of it being bounded by the x-axis if it's saying do not count the area beneath the x-axis as negative?
and the lines x equals 0 and x equals 4.
So those are your boundaries there, the
Those are
0.
your boundaries. So what it's saying, the x-axis is the equation y equals 0. So your two functions are square root of x and 0. Does that make sense?
Yeah, but yeah, what's the point of it being 0 though if you can't plug anything into it? That's just confusing.
Well, yeah, I guess you're right. It seems we don't really need that because it's going to give us, we get the standard thing is going to give us the area between the curve and the x-axis. So let me just, so you're right, we're getting, what was it, e to the x? Square root of x. So if you were to graph those, square root of x is always on top, minus 0. And you're right, we don't really need that. It's not going to help us. We could just drop it off. But that's, that x-axis is just telling us it's y equals 0 as the other curve. Had it been y equals 1, then yeah, we need to put something there. But it ends up being just extra information that is not important because it goes away, but, and then because they give us the intervals, right? They give us bounded 0 and 4. So they tell us we're going from 0 to 4 anyway. And it's not even yeah, it's all going to be that way. So it seems like we might be doing something wrong, but we're not. It's really just integrate square root of x from 0 to 4.
Okay.
Is that, yeah, you're right though. It's kind of just saying, you know, must be doing something wrong, or it must, what is it, why is it phrased this way? Good. All right. Another question?
Yeah. Number 6 on 14.4 is giving me the business, and I kind of need some help on it. It's like a really complicated word problem.
Right.
Basically, I was doing it the same way that you told me how to do the other ones. And then, but like, I used, so basically like the bottom one is what the students want to pay. The top one is what the college wants to charge.
Yep.
Right. Right?
Uh-huh.
So, but when I did it exactly how you told me to do it with my calculator, I didn't get what I should have got. What, like, it just, I don't know. I also had a different word problem than this. It was slightly different.
Really?
Well, no, the word problem was right, but the numbers are different.
Well, of course, of course. Let me do this. This one's going to take, yeah, it'll take a while. Just to let you know, the exam doesn't have a question like this. It has questions like the ones above here that are more straightforward.
Well, that's reassuring.
What's that?
That's very reassuring.
Good. Yeah. So this one's just to kind of get the concepts down. I'll be honest. I looked at it and says, oh, I don't really want to do this. And I'll tell you what. If you really don't want to do it, I'm going. As long as you do the other 1 through 5, everyone's going to be fine. This one, we'll let this kind of be. If you want to push forward to kind of understand it, I'll do a video on it. But yeah, I need a fresh mind so I might do that tomorrow morning because that's when I wake up with a fresh mind. And by this time, I've been doing math since like 6 in the morning. And
I feel you, Don.
Yeah, so we'll do this one, but just don't worry about it because it won't be on the test. It's really just here to kind of help you. I guess maybe to frustrate you in reality, but yeah, I'll take a look at that. It's
okay. Thank you.
You're welcome.
Oh, do we have the quizzes? Are they going to be posted today or next week?
I'll get the first one over the weekend, and I'm hoping to get them all 3 done maybe this weekend. And again, those will be things I'll probably do tomorrow morning or maybe this evening when I refresh my brain a little bit. But the goal is, yeah, they'll be organized around here. So I'll do one quiz with about 10 questions on these three, one quiz with about 10 questions on these. And again, I'll work through, well, the quizzes are there to just kind of get you some practice. There'll be multiple choice.
I have another question.
Okay.
The quizzes, so like there's like 5 or 6 or so quizzes throughout the semester.
Uh-huh.
Is the lowest score of each category from the homework and the quizzes, are they dropped, the lowest score? Or was that?
Well, if you look at the grades, I'll tell you, I just went ahead and put everyone at the full value. I'll be, what I'm looking for is as long as you've gotten one section where you've gotten all the points or did all the homework, I'll just make the homework grade. Because to be honest with you, the homework grade and the quiz grades, they don't, that's 25%, I guess that helps. But I would like everyone to have 100% on those. So yeah, as long as you've engaged, and if you miss some at the beginning, I'm not going to worry. I'll just drop them all as long as you do if you do the last 3 quizzes, I'll do that. So I'll kind of give you that, whatever gives you 100%.
Love it. Thank you so much.
But I would work especially on these last 3 quizzes to get 100% because that will boost your score on the final test as well, which is the way I've got it now rates the last test as the highest value, which is actually going to help more people get either passing or higher grades. However, if you don't do well on the final, but you did well on the other ones, I'll also use that other process that will give you, that'll even it out. But the way it is it's really, if you didn't do well on the first 2 tests, as well as you would have liked, the best thing to do is just really focus on this last one. I worked with someone last night just to kind of see what their grade was, and they did, they were under 30%, let's put it that way. And yet if as long as they got like about a high 80 on the final test, they will still pass the class. So basically I'm allowing this last test to count as a third and the final test. Which, the content-wise, that's really what it's doing. It's going back and it's reviewing a little bit of everything that we've covered. So I think it's appropriate. And instead of having to take 2 tests to get it, we're just doing it all in one test. So work hard on this one test, and it's going to allow people to pass who would have had to do well on a third and a final test. We're just putting it all in one roof. And
Thank you, Professor. Have a good weekend.
You too. So study hard for this last one. It'll pay off for everybody.
Thank you. Bye.
Yep,
Thank
have
you.
a good one.
Take care. You too.
Okay, Professor, I've got a question. And
Okay.
yeah, for the final exam, are you going to use lockdown browser, or we just did what we did like last time, use Zoom meeting?
We will just use a Zoom meeting like last time, because with the lockdown browser kicks out Zoom meeting. So yeah. So they decided they could do one or the other. So they decided Zoom meeting is better, at least. Yeah. So we'll do Zoom meeting, but no lockdown browser.
Okay, good to know. Okay, thank you.
All right.
Have a good night.
Thanks. Good question. Take care. Anything else? We all good? Awesome. Take care. Be safe. I'll post the recording. Thanks.
Thank you, Professor.
Thank you.